Okay guys, so I wanted to go over a few more blood typing examples just to give you more practice with it. And then we'll go over sex-linked inheritance, and we'll probably start pedigrees today. Maybe not get too far into them, but we will at least start them. So, blood typing. Now, so far, except for the last example we went over last time, I gave you the genotypes or the phenotypes of the parents, which, yeah, they make it pretty easy. What if I did something different? What if I said there is a child who has, let's say, A blood. Now that is a phenotype. I gave you the phenotype there. Let's say this child's mom has O blood. And I can word this two different ways. We could say what are the genotypes or what are the phenotypes. Genotypes make it harder, but so we'll start with phenotypes. What are possible phenotypes of the father? Okay. So we know mom is going to be OO. We know that somewhere in one of these boxes, we don't know which one, but the child is A, so we know that in one of those boxes we can have an AA or an AO. Now, given what the mom has here, mom has O blood, we know that the child has to have AO because the mom's going to give her an O. So, or him, whatever. But anyway, so we know that the mom, if we carry her O's over, yeah, we know that one of those alleles for that child has to be an O. So the dad, we got to determine what could be over here. Well, the dad could be A, O, and then we could have AA, OO, and this would be one of the child's here. So what are the possible genotypes of dad? Or, I'm sorry, phenotypes of the dad? He could be A. Could he be something else? Let's see here. Well, if the dad is B, that's not going to make any sense because we need the child to have an A, and the dad has to give it the A. So we got A. Dad can't be O because the kid would just be O. Dad could be AB would be the other one. All right, so it could be, dad could be A or AB. Those are the only two phenotypes. If we wanted to make this harder, what are the genotypes? And to make this kind of easier on you guys, if you're asked what the genotypes could be, determine the phenotypes first, because we can go off of that pretty easily. We know it could be A or AB. Genotypes, well, AB is just AB. That's the genotype of AB. A could be AO or AA. All right, so those are your genotype answers. AB, AO, or AA. Okay? Like I said, guys, I just want to go over one more example with you just to show you a different perspective from things. If you are given maybe a child's genotype or a phenotype, like in this example, and you're not given one of the parents, it makes it a little more difficult. Okay, so let's go over our last form of inheritance, which is called sex-linked inheritance. Now, so far, complete dominance, incomplete dominance, and codominance, all of those forms of inheritance are going to be on our autosomes. For humans, that's going to be chromosomes 1 through 22, or if you wanted to talk about individual chromosomes, it's number 1 through 44. All right, we have 3 pairs, and the first 22 pairs are our autosomes. Now, sex-linked inheritance. These are things that are inherited on your sex chromosomes, on your X and your Y. All right, now, if you remember from the karyotype, our X is larger than our Y. Now, just like anything, if something's bigger, it's probably going to be able to carry more. So the X being bigger is going to carry more traits than the Y. Now, with that X being bigger, it's going to carry certain traits, and those traits probably, well, actually, they're not going to be on the Y at all. Okay, so think about this, guys. Women, you are XX. So women have two X's. Males, males are XY, meaning they have an X and they have a Y. So there's going to be certain traits, and this has nothing to do with your gender, guys. Okay, so we're going to go over traits that are on your sex chromosomes, but they ain't got nothing to do with your gender. So if women have two X's, they're going to be able to carry two alleles for that trait. Okay, I'll give you an example of one. One is color blindness. There are a lot more colorblind men in the world than women. Why this is because if this is a man's karyotype here, they got the X and the Y, right? For sex-linked traits, they're going to be carried on these two chromosomes, right? But it's mostly going to be the X. So let's say right here is where the trait is for color blindness. Go over to the Y, there's nothing there, okay? So males are going to only have one allele for that trait for color blindness. Where if we look at a female karyotype, go to the next one here, females, they got two X's. So they are actually going to have two alleles for that trait for color blindness, okay? And I'll go into deeper depth with you with this stuff, guys, don't worry. So here are some examples of different traits that are on our sex chromosomes. Now, these ones are all going to be on the Y. These ones are all going to be on the X chromosome. The Y is very small. The Y does not carry many traits. The X is what is going to carry most of these traits. Now, that's not saying the Y carries no traits. There are traits on the Y, just not as many. I know if you're seeing the people that are covered in hair, I'm not talking about like, oh, look at that, she has a bit of a mustache over there. No, I'm not talking about that. I'm talking about like literally like their face, they look like a werewolf. That is a trait on the Y chromosome. Since women don't have that Y chromosome, they can't have that trait, okay? But here are some. These are all on the X. Color blindness, that's on the X. Male pattern baldness, you know, when guys get that, you know, like ring where it's all balled up here, that's male pattern baldness. Hemophilia. Hemophilia is when you do not have thrombocytes in your blood. You're like, Communal, what's a thrombocyte? That's when you don't have platelets in your blood. Communal, that didn't help. All right, so thrombocytes or platelets, these are things that clot your blood. If you ever got cut somewhere, you will see these little, it's like an orange crystal structure right where you got cut. And that helps to clot your blood so you stop bleeding. People with hemophilia don't have that, so they have to be very careful because if they get cut, they could technically bleed out. 4, muscular dystrophy. Your muscles start to atrophy. You have a very low life expectancy. And the last one, I've had students with this in the past. It's called ocular albinism. Your eyes, they kind of don't focus real well, and it is almost like your eyes have the albino condition to them. But it's just one other trait. So let me show you guys how to set up a Punnett square for sex-linked inheritance. Right? This one is much different than our other three. Other three we went over, complete dominance, incomplete dominance, and codominance. They were pretty easy. This one involves a little bit more stuff to it. So let's start the problem, guys. A woman is pregnant with a child. She is a carrier for color blindness. Her husband is not colorblind. What percent chance does the child have to be colorblind? We later find that the child is a boy. Knowing this, what chance does the child have to be colorblind? Okay, so I figured we would start with an example for sex-linked inheritance because I think this makes it a little bit easier for me to explain to you. Now, so far, complete dominance, incomplete dominance, codominance, it didn't matter if it was a boy or a girl. This is where it is going to matter if it is a boy or a girl. For our intents and purposes, all of our traits, like I said, are going to be carried on the X chromosome, not the Y. We're not dealing with the Y. So I'm just going to kind of step away from the problem for a minute, and we're going to talk about women, and over here we'll put men. Okay, so a woman, X, X, men are XY. Now, all this stuff, like I said, guys, only carried on the X. So, here's what we're going to do. Color blindness. This is sex-linked recessive. If you have a recessive genotype, you will be colorblind. So, this goes right back to complete dominance. We're just going to do complete dominance with sex-linked. There's nothing more we're going to do with it. So, a woman, again, guys, only the X carries this. So, a woman could be, I'm just going to use R, big R, big R. Woman could be big R, little r. Or she could be little r, little r. Okay? So, if the woman is big R, she is going to have normal vision. It's complete dominant sex linked, so if she is heterozygous, that little r, which is the allele for color blindness, is going to be masked by the big R, so she also is going to have normal vision. However, the last one, this woman will be colorblind. So, big picture. For a woman to be colorblind on both of her X sex chromosomes, she has to have a recessive allele. Again, for a woman to be colorblind on both of her X chromosomes, she has to have a recessive allele for colorblindness. Let's look at men now. Remember, I know I keep saying this, I apologize, but only the X is going to carry these traits for sex-linked inheritance. A male, X big R, Y, nothing. Okay? For this one, he's going to have normal vision. Males are not going to have two alleles for this because only the X is going to have that allele. X little r, Y, the male is colorblind. Take that in for a second, guys. Look at the difference between women and men. Women have three different genotypes, three possible genotypes in sex-linked inheritance. They could be homozygous dominant. They could be heterozygous. They could be homozygous recessive down here. Out of those three genotypes, if you look, two of them, 1 and 2, the woman has normal vision, no color blindness. But if you look at the third one down there, or homozygous recessive, the woman is colorblind. So, a woman has two genotypes that save her from a condition, but she has one where she can get it. So, 2 out of 3, she's good. Look at the male. The male only has one genotype that is going to give him normal vision, and that's the first one there. The other one, the male is going to be colorblind. So, only one genotype saves the male. where 2 genotypes saves the female from having a condition. This right here is why more men are colorblind than women. Because the males only have 1 genotype that saves them, the women have 2 genotypes that save them. Okay? Now let's talk about one more thing. Who made the men colorblind? Well, you have 2 sex chromosomes. You have an X and a Y. If you were a male, your dad in the sperm contributed the Y. The woman, mom, contributed the X. What this means is that the woman, or your mom, contributing the X, if you are colorblind and you're a male, your mom giving you the X, that X had that colorblind allele. And that's why you have colorblindness. Okay? Now, let's take all this from what we know and let's do the problem now. So, a woman is pregnant with a child. She is a carrier for colorblindness. So, carrier. That means she's heterozygous. So, we're going to say mom is X big R, X little r. Her husband is not colorblind. So, he's X big R, Y. Do your Punnett square here. Okay. Trying to keep everything color coded for you guys to make it easy. Okay. What percent chance does the child have to be colorblind? So if you look here, this one is good. Here, I'll label them for us. Let's get some numbers in here. This is 1, 2, 3, 4. Number 1, no color blindness. Number 2, no color blindness. Number 3, no color blindness. But number 4 is colorblind. So the answer to this first question here, 1 out of 4 or 25%. Okay? We find out later that the child is a boy. Knowing this, what chance does a child have to be colorblind? So we know, so this is your answer for number 1. Number 2, here we'll say that's number 1. That's number 2, so we don't get confused there. We know the child's a boy, so we know that these two, they're girls. We don't have to worry about them. Look here. This one, number 3, is good. Number 4 is not good. So there's only 2 males here. One of them is colorblind. 1 out of 2 is a 50% chance. So if it is a male, there's a 50% chance of being colorblind. Okay? That is how you do sex-linked inheritance. Okay. I already did that with you guys. A woman marries a man who has hemophilia. The woman does not have hemophilia, but is a carrier for the trait. So, hemophilia, again, it's recessive, so we'll just use B's here. She's X, big B, X little b. He has hemophilia. So he is X little b, Y. What percent chance does a child have for having hemophilia? All right, I'm not going to color code all this, guys. One, 2, 3, 4. Okay. Question number 1. What percent chance does a child have for hemophilia? 1, no hemophilia. 2, hemophilia. 3, no hemophilia. And 4, hemophilia. So that's 2 out of 4. That's a 50% chance. What percent chance does a female have for hemophilia? Well, if we're talking about females, these are both guys. Get them out of the way. 1 out of 2. It's a 50% chance right there. Still, same thing. Okay? All right. Kitty. All right. We'll go over this example next time, guys, just to give you a little bit of a review. I didn't get the pedigrees today. I don't want to go too far over, but I think that's enough for today, enough for you guys to chew on. We went over a lot, right? So have a good rest of your day, guys, and I will see you next time.